All right, my job today in precalc is to teach you about horizontal and vertical asymptotes. All right, so this is a lot related to what we just finished. Would you agree that on our last test, we learned that x could not be -7 because it would make this equation have a 0 on the bottom? All right, but what we didn't talk about, I mean, I mentioned it, but I didn't really reinforce it much, was that means at -7, there's a dotted line here, and that means that that function can't exist there in a special way called a vertical asymptote. We'll just abbreviate it VA. Everybody write down VA. It stands for vertical asymptotes. So the things that made the bottom 0, you know they're a big deal, those are the vertical asymptotes. So instead of just saying this now, which is what we said on the last test, we say x equals -7 is the VA, the vertical asymptote. Whatever makes the bottom 0, vertical asymptote. Classic mistake, and x equals -1 is also a vertical asymptote. No, we don't care if the top becomes 0. Some of you missed that memo on the test. A lot of you missed that memo on the test. And you set that equal to 0. No, there's no square root there. There's no restrictions on that. So this does not matter. The top doesn't matter. All right, how about the horizontal asymptotes? I'm going to go back and rewrite that same problem, y equals x plus 1 over x plus 7. And the horizontal asymptotes, you might assume that they come from the top because, the verticals come from the bottom. But you're wrong. It's not coming from the top. The horizontal asymptotes are what the function is headed towards in the long run. Would you agree if we had a typical function like this guy, in the long run means if I keep going over to the right, would you agree this just keeps going up and up and up and up? Okay, so then that means that there is no limit to it. It just keeps going forever. But did you know that there are some functions that level off? There are. I'm going to show you one. The population of deer in Minnesota, if you introduce 2 deer, a male and a female deer in Minnesota, that's all it would take. And all of a sudden they're going to have baby deer. And all of a sudden it's going to grow. And over time, you give it 100 or 1,000 years, eventually, do you think the deer population is going to keep going like that? No, eventually it has to stop. Otherwise we'd be pushing deer aside to get to the school building in the morning. You know what I mean? There'd be so many deer. So does it really go up forever? No, there is some limit to how many deer there will eventually be. This one levels off, and there is a limit. And you can actually ask a scientist, and they can tell you, this area, the max number of deer there'll ever be is this. Now, in the real world, some of you are like, yeah, I've heard that you can have too many deer, and then they die off, and then, then they come back again, and then they keep on going back and forth all around this limit number, like the highest that it can be. Okay, so that is called a horizontal what? Asymptote. So we have to figure out from the equation that we give you what the horizontal asymptote is. And here's how you do it. Would you agree that we're moving way to the right? That's what we cared about, right? Is way over to the right. That's like x is a really big number. Like let's say x is 1,000. So that's what I want you to do. Everybody put 1,000 over this and 1,000 over this. Now, if I asked you, how much money do you have, and you had $1,001, would you agree it'd be kind of logical to just say, I have about 1,000? You're not going to say, I have $1,001.04. That'd be dumb. So you're going to kind of say about 1,000. And you can, I know this doesn't seem like math, but you can say 1,000 or 1,001, it doesn't make any difference. So just cross off that little +1, doesn't matter. Would you agree the same thing happens on the bottom? If I have 1,000 and then I add 7, I have 1,007. I know, but it's about 1,000, right? So scribble that off. And so now we have about 1,000 over about 1,000, and what's that equal to? 1. So that's where the asymptote is. That's the limit it'll go to is 1. I know this isn't a logical one for deer population. The deer population won't be 1. But y equals 1 would be my, what kind of asymptote again? Horizontal. Now, if you ever want to have a little trick for remembering which one's the horizontal and which one's the vertical, I'll give you, because like you're going to sometimes have an answer of x equals 5 and y equals 3. And you're going to be like, dang it, which one's the horizontal and which one's the vertical? People get them confused. If you don't get them confused, awesome. But here's a way to remember it. Write this down. Vertical and horizontal. I know this is dumb, but it works for me. If I see like x equals 5, I can go in my head, oh yeah, that's the vertical asymptote. You know, the verticals are the x equals ones. And that may seem like a really big deal, or a really small deal, but on the test, we're going to have 2 blanks. One's for the horizontal asymptote, one's for the vertical asymptote. And do you get that all the time? Kids put the wrong ones in there. They like, I know it's y equals 5, but is it the horizontal or is it vertical? I don't know where to put the y equals 5. And if you just write y equals 5, and then you go horizontal. Oh yeah, it's, what was that dumb word he told me? Horizontal. Oh, that's the horizontal asymptote, y equals 5. Same deal if you have an x equals 2 or something. Vertical. And that helps you remember where to write your answers. Otherwise, when I give you a problem like this, y equals 2x minus 3 over x, and then I say, what's the horizontal asymptote? What's the vertical asymptote? If you put them in the wrong spots, I have to mark them wrong. Are you going to know which one's which? Break out those dumb little words. All right. So right now, I hope you can look at this and go, okay, the verticals, they come from the bottom. And so I know what that vertical asymptote is. Boom, done. For horizontals, you're going to want to stick in 1,000. It's just the easiest way to do it. Could you put in like infinity? Yes, but it's weirder because all of a sudden you have 2 infinity over infinity. And people get confused by that. But if it's just 2,000 over 1,000, I think you'll know what to do. All right, give this one a try. Figure out the horizontals and the verticals. Remember, verticals come from the bottom. Horizontals come from putting in 1,000 and simplifying it. Give it a shot right now. Ben Crab, I want to talk to you for just a second about stuff. You don't have to bring your stuff. Just come for a second. In a moment, you're going to compare your answers with the kid next to you. I know, I just taught you for like 2 seconds. Let me joke. But I need to stop the video here. Well, you guys give this a shot. And then talk to the kid next to you. I know you may not get it quite yet, but maybe the kid next to you can show you. Horizontal asymptote. All right, the horizontal is the one where you do the 1,000 trick, right? 1,000. And would you agree that 2,000 minus 3 is pretty much still 2,000? Okay, so then it's over 1,000. And so can you help me understand why the answer is what it is?
Because 2 times 1,000 is 2,000, and 2,000 over 1,000 can be simplified to 2 over 1.
You got it.
And what's at the top is 2, and that's the horizontal asymptote.
The horizontal asymptote, y equals 2. I put it in the right blank, did you? Some kids are going to put that over in the VA category and they'd get it wrong because that wasn't the vertical. Any questions on that? You put 1,000 in, and then you got 2,000 over 1,000, which pretty much is 2, because 2, the 1,000's canceled. So it's pretty much y equals 2. All right, and then the vertical asymptotes, those are whatever makes the bottom 0. And what makes the bottom 0 is x equals 0. And just a quick check, the verticals are the vertical asymptotes. I put the x in the right spot there. Okay. All right, let's do one more like that. Y equals, and if you can factor it, you should. Now they're going to ask for the horizontals and the verticals. This time, I'm going to ask for the verticals first, and then the horizontals. You have to know where to put them. Keep them straight. Remember, for the verticals, it's just whatever makes the bottom 0. For the horizontals, that's the one where you put in 1,000. Now, some of you are not going to get what to do at the end of this one. Would you agree subtracting 36 when you're talking about 1,000 squared, the minus 36 almost does nothing? So I know it seems weird in a math class, but you could kind of round these and say, well, that 36 doesn't really matter. Even if it's 36. Because compared to 1,000 squared, it's pretty much nothing. It's kind of like to Bill Gates, somebody who has multi-billions of dollars. If he loses $100, he doesn't care. If you only had $100 and you lost $100, that would matter. Okay, so we're putting in 1,000 here and 1,000 here. And that's to do, which kind am I going to get? Horizontal or vertical on this one? Horizontal. And you get y equals 1,000 over 1,000 squared. I want to show you what that really means. 1,000 squared, doesn't that mean 1,000 times 1,000? So doesn't this cancel? So some people that are really bad at math think the answer is 1,000. Do you get there's actually a 1 on the top? It's 1 over 1,000. Now again, this is all about like kind of rounding. Would you agree if I said, here's our pizza and you get 1/1000th of it? That's pretty much nothing. Then you can round that to 0. Because 1/1000th isn't 1 over 1,000. 1/1000th of the pizza is if you cut it in 1,000 pieces and you only get one of them. You get that's pretty much 0. All right, there's lots of rounding involved here. You have to understand that 1 over 1,000 is pretty much 0. Is it really 1,000? No, it's actually infinity. 1 over infinity is infinitely small, so it's definitely 0. So that's the answer, is y equals 0. And which one is it? The horizontal asymptote. The vertical is whatever made the bottom 0. Did you factor it into x plus 6 and x minus 6? If not, then you haven't learned to factor yet, and you gotta fix that. X equals -6 and x equals 6. There can be multiple vertical asymptotes. So remember what this means on a graph is that if I put in -6, this thing won't exist. So if I made a picture of that, it would be 6 and -6. Those are the vertical, horizontal asymptotes. And the vertical asymptote is at 0. Now, we aren't even asking you to graph it. If you were in honors, you'd have to graph this, which is gross. All we're doing right now, today, is just telling you what the vertical and the horizontals are. To actually graph it, you'd need an XY chart because it's your best friend in graphing. And you'd have to find a whole bunch of points on there and you'd end up, like once you have the points, it's super easy. And you go, oh, I guess all it is like this, and this. There'd be some points here and that. But you have to find all the points and that's the real pain in the butt part. All right, but you're not in honors, you're in regulars. So today, all you'd have to do is tell me the vertical and horizontals. So let's do one more. Are you ready? Hint, this is harder because there's fractions involved. Figure out the vertical asymptote, and sometimes there's more than one, and the horizontal asymptote. The most there ever is on horizontals is 1. There's only ever 1 horizontal asymptote. Verticals, you can have a million vertical asymptotes. Okay, give this one a shot. All right. Verticals. That comes from here. Ava, how do I find the vertical for this? No, that's the horizontals. How do we figure out what makes the bottom 0? you set it equal to 0 and you figure out what makes the bottom 0. Mr. Sexton, can you finish this equation? We're doing the verticals right now, so we're going to get an x equals thing here because I know vertical and zertical go together. So I'm solving for x here, and Mr. Sexton, tell me what to do.
Subtract 5 from both sides, and then divide both sides by 2.
And there's your answer. X equals negative 5 over 2. How did I know to put that under vertical? Because I know x kind of goes with vertical because it's like zertical. And then there's the horizontals. Horizontal asymptotes, of course, go this way, and it's like a limit. Like I said, the deer population couldn't go to infinity. The highest we could have in Minnesota might be like 20 deer per square mile or something like that. Then that's just the limit. That's the highest it goes. So what's our horizontal for this? Well, that's the horizontal asymptote. It's a y equals thing, and that's the one. Ava, would you put in 1,000 and tell me what to do now?
I got 3,000.
Over.
2,000.
Yep.
So 3 over 2.
Yeah, exactly. You got 3,000 over 2,000, so then you said, so that's like 3 over 2. You are correct. And that's where it's going to end up. Y equals 3 over 2. That's about 1.5. If you said 1.5 or 3 over 2, I'm good with that. There's your horizontal. There's your vertical. What makes the bottom 0? Do you have any questions about that? And like, is there any part of that that you don't understand? I would really respect you saying, I need you to re-explain this. All right, then, here's your hardest one. This is almost not fair. But you can still use the techniques I showed you. Verticals, hopefully you know the difference between the vertical and the horizontals. If somebody has a catchy way of remembering that the horizontals you want to put in 1,000, I haven't got a nice little trick, but the horizontal is the one where you want to put in the 1,000. I'm just thinking some kids are not going to know what to do with all those thousands. Remember, it's kind of like radical rounding. You go, that doesn't really even matter much in the big picture. If it seems like it matters, put in like a bigger number, like 10,000, or like 100,000, or like 1,000,000, and see, I wonder what it would simplify to. If I could just kind of round off stuff. Yes, sir.
What if we find a problem that actually has a really big number in it, like 1,000,000 or 1,000,000?
It would still be the same concept. So if this 3 right here was actually 3,000,000,
Then you just put in a bigger number?
yeah, then you just have to put in something like, I don't know, 1,000,000,000,000. The point is, actually, when you get to that point, you start saying infinity. And if you get good enough at this, you can go, if it's infinity over infinity, oh, that's just 1. Or if it's infinity over 2 infinities, oh, that's 1/2. You know what I mean? You start being able to cancel off infinities too. So use infinity when the numbers get really big. Okay, I know that a lot of you will have one of these answers because you'll be able to factor them and but some of you will get confused does the top matter? Well, on the one kind, the top doesn't matter at all. On the other kind, you got to put in the thousands. All right, I'm going to pause, check with the kid next to you and see what they think. All right, I know that the fundamental problem for some of you is that you couldn't factor these. And that's one of those things where I keep on saying that first 20, it's so critical because it's got factoring in it in like 3 different ways. So if you couldn't factor these, you got to get better at your first 20 or you're not going to make it in this class. Because at this point, those basics are showing up all over the place. And this next test is the one that's got the most algebra on it yet. And so if you're still struggling with like a 13 out of 20 on that first 20, I had you all do that, you know, on the async day. If you're that kid, then you're probably going to be retaking this next test. And it still might not go well if you don't get the algebra down. Okay, so you got to know how to do this stuff. This top one was easy peasy if you know what you're doing. And I'm just going to double check it here by going first, x squared, outside 1x, inside negative 4x, and does that together make negative 3x? Yes, it does. So I factored it right, yay. Oh, and I should probably check the lasts. Every now and then a kid messes these two up. That times that has to make negative 4, and it does. Okay, so yay, I can factor the easy ones, but can you factor the hard ones? Like this one, had an x in everything. That's called the GCF. The x factors out to the front. And then you'd have x squared minus x minus 2. If you didn't know that by now, oh my gosh, you're going to have so much pain. You got to learn to factor. I just know where you're headed. And this is where you're headed. All right, so look how double checking myself, making sure I factored it right after all of that. Nope, I didn't. There's a plus there. Yep, there we go. Now, I mean, I'm not saying you can't make dumb mistakes. Everybody can make dumb mistakes. But if you don't know how to, then that problem would be toast. And you get that there's only 4 R3s. You get one wrong for a dumb mistake, and you get one more wrong, you're down to a B. You get one more wrong, you're down to a C. All right, so what makes the top 0? I don't care. What makes the bottom 0? 3 things. And these are the vertical asymptotes. X equals 0 for that first thing. Did you forget that one? X equals 2 for this one. And x equals negative 1 for that one. There were 3 vertical asymptotes. Whatever makes the bottom 0. Okay, and then whatever makes the top 0, I don't care. Doesn't matter. Some of you got that mixed up on this last test too. You were like trying to make the top 0. It doesn't matter. 0 can be on top. 0 over 25 is just 0. No big deal. Okay, and now we have to go to next level, which is the horizontals. That's like the putting in 1,000 deal. So now that I got it factored, is the time to put in the 1,000. Telling you, it'll work way better. Putting in the 1,000 in this, you're going to get really confused about whether that 3 times the x like matters. But if you put the 1,000 in here, it'll be really obvious. Do you agree that 1,000 minus 4 is pretty much 1,000? Do you agree that 1,000 minus or plus 1 is pretty much 1,000? So then the top is 1,000 times 1,000. That's not pretty much 1,000. That's 2 separate 1,000s. That's a big deal. All right, and then I'm going to put 1,000 here times 1,000 here, and minusing 2 really doesn't do anything, right? And then 1,000 here, the plus 1 doesn't really do anything. So I got 2 1,000s being multiplied over 3 1,000s being multiplied. I'm going to write that out more clear. That over and now I can go cancel, 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 cancel. Is this equal to 1,000? Careful. No, what is it equal to? And what is 1 over 1,000 pretty much? 0. If I said, I'm going to give you 1/1000th of my cookie, you probably couldn't even see it. It's pretty much no cookie. So there's your asymptote, y equals 0. That means in the long run, one of those kind of functions has an asymptote, runs right along there, horizontal asymptote. How do I know it's horizontal? Y equals horizontal. I got that connected in my head. So if I see y equals, I know, oh, it's a horizontal. Or the other way around, if I know I have to have a horizontal answer, then I know it has to have a y equals. All right, you learned everything for this homework. There are a few that you can skip. Everybody find the homework, and then these are the ones we can skip. Numbers 6, numbers 14 and 15, and 18 and 19. I'm just trying to keep your assignment reasonably sized so that you can get it done between a few minutes in class and a few minutes at home. if you aren't doing anything at home ever, if it's only because you're really efficient, like you do your homework on the bus, that's just being smart. But if you never have to do homework outside of this class, then you're taking a class that's a little too easy for you. You should be having to do some of this at home. If you can finish it all during a work time, you're probably taking a class that's a little too easy. All right, so in other words, you shouldn't have too much homework, but you should have some homework. Number 1, Ainsley, could you read me a problem? Numero uno. All right, and they want the horizontals and the verticals, right? Claudia, which one do I do to get the horizontals? What kind is that?
That's the one where you insert a
Excellent. And I would always write y equals in front of that so that I remember it's y equals. What do you guys say? Y equals 1. How about the verticals? If you forget, you just say vertical, and I hope I made that stick to x. X is vertical, zertical. It's x equals something. And it's what makes the bottom 0. There you go. Remember, on the kind that can be factored, you should, because when you're sticking 1,000 into this, you're going to get confused otherwise. If you had to, like, stick 1,000 into that. So instead, you factor it and you go x is in both of them, so it's x times x plus 3. And then when you put in 1,000, you'll be like 1,000. And 1,000 plus 3 is pretty much 1,000. That's like 1,000 squared. Now, just to clarify, what if you just had that? And your answer was y equals, I don't know, like 1,000,000? Does that mean that there's an asymptote at exactly 1,000,000? No, that means that there is no limit. Remember, you're really putting in like infinity. It's like infinity times infinity. It's like the ending of this graph, when you go way over here, you put in a really big number, is that it is infinitely high. That means that there's no asymptote. So there could be an answer of there is no asymptote. If you get an answer of like 1,000,000, it doesn't mean it stops at 1,000,000, because you're supposed to be putting in a really big number. Then try putting in a infinity and see, oh, I guess it's infinity. It would be really dumb for you to say y equals infinity, though. You're saying I should put an asymptote at infinity. That's not a thing. There's no limit then. There isn't an asymptote. So if you ever get this, check yourself before you wreck yourself. That means there's no horizontal asymptote if that ever happens. Okay, now you got a bunch of time to work. I'm going to be quiet and let kids work, and then you can come up and ask questions. And that's all I have for you for the video for today.